There's a couple things I also want to hint on during our separation step. I said that you have to use cold dilute HCl in order for the separation to occur. And I want to hint on why we need to use cold and why the HCl needs to be dilute. So the HCl must be cold to ensure all of the lead 2 plus is removed from solution. Remember that solubility is highly dependent upon the temperature that you perform your experiment at. So in this case, we're trying, the lead isn't quite as soluble as the silver is. So if we make it as cold as we can, there's going to be a step that requires you to go out and get some ice from the cart. You need that ice to make sure that as much of the lead precipitates out as you want. The HCl must be dilute to prevent complex ion formation. And the complex ions that could potentially form are AgCl2 minus, PbCl3 minus, and PbCl4 2 minus. I really like this solubility experiment because it can help us emphasize a lot of the factors that influence solubility. I'm going to briefly introduce these complex ions right here, and we're going to talk about them into a lot more detail probably Wednesday of this week. And we're going to talk about when these complex ions can form and what we need to look for in order if these complex ions will form or not. But we will really drastically influence the solubility by observing complex ion formation. And what happens back in the history of the chemistry and these experiments is that everybody starts to perform experiments, and then they have a hypothesis. And then they go into the lab and they perform the experiment, and it doesn't work the way they thought it would. So they have to come up with a different, reason why it would work in one case and not in another case. So for example, if you add dilute HCl, you can precipitate out all of the silver and the lead. But if that HCl is concentrated, all the silver and the lead don't precipitate out. So we have to come up with a reason of why that is, and that reason why is this complex ion formation theory. And we'll talk about that, like I said, in Wednesday. Yeah, there's a question?
Does this imply that for solid sodium chloride to dissolve as an exothermic process?
There's no implication about endothermic or exothermic based on these observations right here. You'd have to perform further tests for that. Okay.
Wouldn't that affect whether or not we using a cold HCl versus non-HCl?
Yeah, I mean, the temperature and cooling a solution versus heating a solution, the thermodynamics will come into play with that. But again, we'll look at that when we go into chapter 19 a little bit more.